Then we have the early start for number 17 is the early finish for number 16. 18 is only preceded by 17, so it must equal the early finish of 17. 19 is going to be the max of both 18 and 17. 20 is going to be the max of 18 and 19. 21 will be the max of 20 and 17. And then 22 would just be the early finish for 21, and so on until we reach the end. Right, so now that we have the earliest possible finish, it's also the last step, so we know that must also equal the late finish, and the early finish must be the same for the last step. Then we proceed going backwards this time to calculate the late finish and also the late start. So 23 is followed by 24. The late finish for 23 must be the late start for 24. So that equals that. Same for 22. Must equal the late start of 23. And same for 21. Now, so 20, as it's only followed by 21. So we know that the late finish here must be the late start of 21. Then for 19, again, it only goes to 19 is only followed by 20. So we know that the late finish must equal the late start of 20. Now here we have 18. 18 either goes to 20 or it goes to 19. So we know that it must be one of the late starts from either 20 or 19. Because it's the late start, we want to take the minimum value of these two. So if we enter minimum, and then we take the late start for 20 and the late start for 19. And there you see we have the minimum value. So you can see here that the late finish for number 18 is the same as the late start for step number 19. Now, if it was the late start for step number 20, then you'd have 65. This would mean that the late start for 19 would have to be 65 as well, because the late finish for 19 can't be done until 18's been done as well. So the late start must be the minimum value out of the two options here. Now, number 17, we know goes to 21, goes to 18, and goes to 19. So again, we take the minimum value between those three. The minimum value of the late start, 19 and 18. 16 is only followed by 17, so it must equal that. Number 15, again, only goes to number 16, so it must equal that. Now, number 14 goes to both 15 and 16, so again, we take the minimum value of 15 and of 16. 13 only goes to 14, so the late finish equals the late start of 14. 12 again only goes to 13. 11 only goes to 12 as well. So again, 11 must equal the late start from number 12. Now number 10 goes to both 12 and 14. So we do the minimum value from both the late start from 12 and the late start from 14. Number 9 again goes to 10, 11 and 12. So we take the minimum value of the late start from 10, 11 and 12. Eight goes to both 9 and 10, so we know that will be the minimum of 9's late start and 10's late start. Number 7 only goes to number 8, so it must be late start from number 8. Number 6 goes to both 8 and 7, so we take the minimum value from the late start from number 8 and late start from number 7. Number 5 only goes to number 7, so we know that must equal the late start from number 7. Number 4 only goes to number 6, so again it must equal the late start of number 6. Late finish for number 3, so 3 goes to both 4 and 5, so it must be the minimum value between the late starts for both 4 and 5. Number 2 goes to both 3 and 5, so again that must be the minimum value of 3 and 5's late starts. And finally, the late start for number 1 must be the late finish for number 1 must be the late finish for number 2. Now you'll see some errors that come up. Minus 5.77316 e to the minus 15. That's a very small number, and in this situation we can regard that as 0, as it's just a small rounding error by Excel. So I'm going to go ahead and I'm going to change that for a 0. It's also here in 1, so we know that must be 0. This must be 0, and so this must be 0 as well. Which makes sense, as there's no slack time for step 1, so the late start must equal the early start as well. And you can also see here that there's definitely no slack, because if you take 3.64315 and 3.64315, it's the same time for both the early finish and the late finish. So now that we have our chart in place, we need to decide our CPM. We decide our CPM by seeing which of our boxes do not have any slack time. That must be the slowest and longest possible time, which is obviously the definition of CPM. And so we're going to do a little highlight color for each of the steps where there's no slack. So 1, 2, 3, 4, there's no slack. 5, there is slack, as we can see here, so we're not going to include that in our CPM. Critical path is what I mean. Number 6 has no slack. 7 has no slack. 8 has no slack. 9 has no slack. 10 does have slack, as we can see here. 11 has no slack. 12 has no slack. Not 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So because none of them have any slack, they all get a yellow highlight, and they also they complete our critical path. So actually the only two steps that are not involved in the critical path are steps 10 and 5. Okay, so now that we've decided our CPM, we need to figure out how long it takes. So the first thing we're going to do is we're going to make a couple of little columns. First of all, we're going to put the critical path, and that is this number here. So if this was in days, then it would be 85.1987 days would be our critical path. And just to make that a bit clearer, I'm going to put that in bold, and I'm going to highlight it in green. Let's choose a nice light green. That will be. Alright. We have CPM, we also need to find our total variance. So we do a simple sum of all our variances. And now we need to find the variance, the total variance of the CPM. So we'll call that back. So basically for this, all we're going to do is we're going to take the total, but we're going to take away the two steps, step 5 and step 10, that were both not in the critical path. So we're going to take this, and we're going to take away the variance of step 5 and step 10. So this is step 5, you can clearly see here. Take away this value, and we'll take away the number 10 as well, which is this value. And that gives us a total variance for the CPM of 0.0142253132. So now that we have the variance, the next thing we need to do is to find the standard deviation. Now to find standard deviation, all we have to do is do the square root of the variance. And we have 0.1192, etc. Right. So now we have this data, we need to look at question 4, which says how much do you need to adjust your project to have exactly 95.05 confidence of completing on time. So the way we're going to do this is we remember that to find our Z score, we do it equals the expected date, or expected time, minus the CPM, and divided by the standard deviation.